Hi guys, today we're going to conclude our series on volumes of revolution by thinking about what happens to a parametric equation. Now this example here says a curve C has parametric equations x equals t times 1 plus t and y equals 1 over t, 1 over 1 plus t. And really importantly it says t is greater than or equal to 0. So we've got a curve there that's defined parametrically. Now it says the region R is bounded by C, so you can see the region R, the x-axis and the lines x equals 0 and x equals 2. I'll use them later. And find the exact volume of a revolution of the solid formed when R is rotated 2 pi radians about the x-axis. So if I'm revolving around the x-axis, I would say v equals pi times the integral of y squared dx. Now our function is determined or defined in terms of this parameter t. So actually integrating with respect to x is not really the right thing to do. I really want to integrate with respect to t, but then that's a different thing. It's written differently. But if I were to divide by dt here as well, those would cancel out and I would be left with the same function. So this is exactly the same function as that. You probably can't see that because of my hand. So this is how I'm going to progress with a parametric integration. So from this question, I need to know what y squared is. 1 over 1 plus t squared. And I need to know what dx by dt is. Well, x, I multiply out that bracket, I get t plus t squared. So if I differentiate that, I get 1 plus 2t. So my integration so far is going to come to pi times the integral of 1 over 1 plus t squared times 1 plus 2t, so that's 1 plus 2t over 1 plus t squared dt. Now, I've now changed everything to in terms of t, but my limits are in terms of x. So I could really do with changing my limits. So when x equals 0, that means t times 1 plus t equals 0. So t is equal to 0 or minus 1. But we said t needs to be bigger than 0, so I need to ignore that. When x equals 2, t times 1 plus t is equal to 2, so t plus t squared equals 2. Changing that to a quadratic, t squared plus t minus 2 equals 0. So I've got t plus 2, t minus 1 is equal to 0. So t is equal to minus 2 or 1. Again, t is bigger than 0, so I'm going to ignore that. So my limits are between 0 and 1. So actually that's probably the easy bit done. So I've changed it from an integration in terms of x to an integration in terms of t, and I've changed my limits from x limits to t limits. So I've got quite a standard integration here to do, but I need to think, right, how am I actually going to do that integration? I first of all was starting to think, is the top the differential of the bottom? No, so I'm going to have to go down a bit of a different route, and I think I'm going to look at this in parametric equations. Not parametric equations, partial fractions. So 1 plus 2t over 1 plus t squared would equal a over 1 plus t plus b over 1 plus t squared. So if I was aiming to get a common denominator throughout, I would say that 1 plus 2t would be equal to a times 1 plus t. By timesing this one top and bottom by 1 plus t, I would have everything with 1 plus t squared on the bottom, plus b. So I could say, right, so if t equals minus 1, on this side 1 minus 2 is minus 1, and on this side I would have b. If I was just to look at the non-x terms, which in fact are the x to the power of 0 terms, I would have 1 on this side equals a plus b on that side. So I know that 1 equals a minus 1, so a equals 2. So my integral will now become the integral of pi between 0 and 1 of a, which is 2, so that's 2 over 1 plus t, and then b is minus 1 over 1 plus t squared dt, which is now an easier function to integrate. So we're still going to be, the pi is still going to be there. This is going to be 2 ln 1 plus t, and here that's like, because the differential of the inside here is 1, we can almost go straight away and say that's like integrating, a similar method of integrating minus 1 over t squared, which would give us 1 over t. So this is going to be plus 1 over 1 plus t, and that's between the limits of 0 and 1. So when I put 1 in, when I put 1 in here, I've got 2 ln 2 plus a half, and when I put 0 in here, I've got 2 ln 1, well ln 1 is 0, so that disappears, and this is 1 over 1, which is 1. So my final answer is pi times 2 ln 2, and then I've got a half take away 1, which is minus a half. So 2 ln 2 minus a half. So the new thing was how to convert the dark normal formula to the overall parametric formula, and I think it really makes sense to times and divide by dt to change the whole thing to be in respect of t. And from then on, it's just a bit of integration revision. What would you do with that sort of situation? And splitting into those partial fractions is a really common thing to do. And from now on, it was just testing my integration skills. So hopefully that all makes sense to you. This is the key. Thank you.